Hello everybody, welcome to the stream. Let's turn this off for now. Need to take that out of the other scene. How's everyone doing? Welcome. I'm James, you're you, and we're all here, right? All right, microphone's going. Okay, so we're gonna dive right on in because I'm not actually set quite up yet, and we're gonna have to get a couple things going. So we're gonna work on Macintosh schematics. This is March. March is Marcintosh. I had thought about doing this last week, but I wanted to get the MC10 schematic done, and so we almost got there. But we'll have to finish that in April. Or I might just finish that one up offline because it's kind of at the, well, we still have to run DRC, or ERC, so we'll see. I don't know. Anyway, so what I want to do now is, can I go back to the main branch and then create a new branch? And we're going to call this Mac SE. See if this even works. All right. And then I need to go and create a thing. All right, so we didn't have any Macintosh, so I'm going to make a new folder, Macintosh. And then for the moment, I'm just going to do new folder, and we'll just call this the Mac SE. I'm sorry, the Macintosh SE. I think it's a little bit weird. A lot of people say Mac, but I think it really is Macintosh. Oh, you know what? I just realized I shouldn't do that. So let's delete that, and then let's fire up KiCad 8.0.1 RC2, which I think fixes one of the big bugs I kept running into with the previous versions. So let's do a new project, and then we'll go to projects, bit preserve, app, not Atari. Ooh, that's a big mistake. Can't click on that. Macintosh SE, we'll create that. And then we'll open up this. Come on, Windows. There we go. I wish I could just tell it. Okay, we'll save this, and then let me do an initial commit, and then we'll get going. Just like that. Oh my God, why did all that stuff change? That's not good. That's gonna make things difficult. Initial Mac SE commit. All right. So we'll get that going. All right. So this is in my way. What we're going to work from, I found these files last year, right after Marcintosh. Let's see. I will figure out and cite the website later, but the person's name is Andreas Kahn. And so if I look at SE, oh my God, I should have looked at this before I streamed. Oh, are you kidding me? Oh, goodness. This is going to be fun. All right. We will do the best we can. And maybe we can find another. You know what I'm actually tempted to do is I wonder if we shouldn't jump to the analog board, because I actually really need the analog board because I'm recapping an SE. Nah, well, let's start working through this one. I mean, this is gonna be fun. I know you guys have heard me say this before, but I'll say it again. People ask me all the time, why don't you just write a Python script to use OpenCV and and OCR these? Well, here's why. I'm not sure how to write code that can read that. I'm not even sure how to read it. All right, so we should have done this first. We should have created a new library, because I do like having libraries for each schematic. What am I doing? What did I just go to? I went to the schematic editor, didn't I? I meant to go to symbol editor. All right. And for the moment, we can just do new library, and we'll put this into the project, and we'll call this Macintosh SE. And we'll save that. And then I'm going to do a new symbol, and we'll call this the 60. Is it the 6800? Is that? Well, we'll start there. What is the processor in an SE? I don't even know. I can't even read that. This is going to be so fun. I cannot believe this. Oh, is that a 68900? I'll have to wait for somebody smarter to tell me. We'll just start there. All right. So what do we got? We've got address up to 19, A1 to 19 on this side. And then looks like we do 20 through 23 over there. But there's no A0. Okay. All right, well, let's get the address lines, or address pins, because that's a pretty easy one to pin name A1, 29, 30, 31, 32, up to 47, 8, 9. Okay, it looks like they start at 29, and these will be outputs. They're probably tri-statable, aren't they? Maybe not. All right, so we'll start that, and then we'll use trick number 1, which is the insert key. I'm just going to hit insert and create up into pin 23, or address 23. Now, we did miss a pin number somewhere. So who did we skip? 29, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40 on A12. Okay. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 on 19. Okay, so 20, we're going to do this. So 20 actually has A20, looks like 49. And then we'll do insert for the next couple. Well, that works. That works good for me. Okay, so now 8, 20, move this over here, roughly there. That might be good. Okay, so now we have a, let's see, let's do the easy ones. So let's go ahead and do data next, since those are just, we'll just insert key those. Now this will be D0. Oh, and they go backward, of course. Okay, so I'm just going to do D0 and make them tri-state, and then we'll insert the thing. Where's my other cursor? We'll rotate this. Okay, so now we'll do up to D15. And this is 5, then 4, then 3, then 2, and 1. And then D5 is 64, 63, 62, 61, and 60. D10, we'll start with 59, 58, 57, 56, 55, and 54. All right. So we have those in place. Now, let's do these harder ones. I say they're harder only because the names are they're going to be tough to read. I really need to figure out what processor this is, like what the actual one, so we can go look at the data sheet. I guess we need to figure that out anyway. I'm going to assume halt is an input. Let's change that. Clock is pretty likely an input, unless it's a 6502. And UDS, I have no idea what that one is. And so what I'm going to do for the moment, I'm going to make this passive only because I don't know what it is. And that way I can come back later and we can figure it out. I don't want to take the time to go and look it up because I want to get all the pins created and then we can look up what everything is. So pin 24 is IP something. I don't know what it is. I'm just going to say IP for the moment because it's weird because I can't read it here or here. So I'm not sure what happened there. Okay, the next pin looks like VPA. And that's going to be 21. And then what do we have? DTAC? OTAC? I don't know what that would be. LDS. I wonder if that's like a load, some kind of load pin. 8. And then, oh, look at this. Okay, so the other pin, this is IPL0. And it looks like that's a knot. I wonder if the other one is IPL1. Because it kind of looks like IPL0, and I could kind of see like an IPL1. I just wonder why is it dotted out. So, Okay, this one's easy. This is read write. So that's an output. And that is pin 9, probably. This is going to be so fun. BG 11. All right. Oh, I'm going to put that back to passive. Okay. And let's see. BG-AC. So I wonder what BG means. This is a processor that I'm not familiar with, so that makes things a little more interesting. This looks like BR. Oops. That's not how you make an... Okay. Okay, first of all, let's highlight both of these and make them passive, since I'm not sure what they are yet. And then on this one, we want to make this tilde braces BR. Much better. Oh, I forgot to turn this on. Oh yeah, look at that. Okay, so now we'll do another pin. And we'll do ground 16, and this is a power input, which is always confusing to people new to KiCad. Power inputs are for pins that consume from there's creators, or there's providers, and there's users on the power rails. And unless your chip is actually creating the rail, then the VCC and ground pins or power pins are all inputs. It's not a which way is current flowing kind of thing. It's just to represent this is a device that needs something else to be driving the power rails. This chip itself cannot drive the power rail. So, all right, 14, and then we'll copy paste. And this one will be 49. Did I make the other pin number down here? Whoa, that can't be 49. Wait a minute. Oh, wait. No way. This looks like this VCC is pin 49, and then address 20 is 48, and then 21 is 50. Okay. I'm going to go with that for the moment, but that seems weird. All right. 48, 50, 51, 52. Okay. Zoom. So I think, yeah, I did forget this one. This should be 53. Okay, so now, all right, so the data lines are going to come all the way down. We'll put them roughly here, and then we'll bring ground down a little bit more just to make things clean. Okay, so we have these 3 pins, which are FC, it looks like, 0, 1, and 2. What am I doing? P for pin. FC0, and that's going to be 28. And then I'll go ahead and insert for the next 2, even though the pin numbers are going the opposite direction. 27 and 26. All right. And then up here we have an IPL2. So let's go. Yeah, I'm starting. I really think this other one is IPL1. And that's on pin 23. Oh, did I really? I did. Okay, so these 3 pins I messed up. I made these power inputs, which is incorrect. I'm not sure which they are, but they're not power input, that's for sure. So we'll make that a passive until I figure that out. Okay, what do we got up here? E, which on the, what is it, the one for the MC10, I kept thinking that was E for enable, but our friend Squire corrected me and said that that was actually a clock signal, which makes sense. I think these are both the same sort of lineage of processor. Wait, what am I doing? RES, which I'm guessing is maybe that's reset. That is 1 blob. I wonder how you denote blobs in KiCad. I'm going to go with 16 at the moment, and we'll find out later if I'm correct. And then is this AS? So this should be AS, and that's on 6. Oh my gosh. SEAR. Oh my gosh, I hope this is listed. Up here it looks like BEAR. Is it bear? And over there it looks like BEAR. It looks like BEAR. Well, this might be the first schematic in Bit Preserve that is significantly more readable than the sources available. Like, they've all been a little bit smudgy and blurry and questionable, but none of them that we've worked on up until now are as bad as this one. This is something else. Oh, I should have made them all unspecified. That's what I should have been doing. I didn't realize that was an option. Passive is kind of a cheat. If you don't know what else to do, make it passive. But I would rather try to specify them and then figure that out late and then leave passive for the ones that we really don't know what to do with. Okay, so I think that gets us all the way around. What we're going to end up doing now is I'm going to go find the data sheet for the processor and see if we can't get a better pinout. Because for two reasons. One, to try to understand what some of these names are. And then the other reason is just so that we can define the pin functions correctly. All right. That looks good. All right, so I'm going to draw a line temporarily. Let's see, where's the middle of this part? It's right on the 46. Because I like to try and center the, oh, come on. I like to center these after I've put them in here. So let's do that much. Let's move this one at least to there. That should be the center of both axes. Yeah. All right, so let's go with that for the moment, and let's fill this in so it looks nice and pretty. All right, look at that. It's starting to look like we have a part. Okay, so let's pull up the correct way to find solutions, which is not using ChatGPT. And we're going to type in Macintosh SE specs. And it is a Motorola 68,000. But is it an actual 68,000 or is it something else? It's just 68,000, 68,000. Okay. Okay. Motorola 68,000. Pin out data sheet. Let's go for a data sheet. NXP has a data sheet for the 68,000. So Motorola turned into Freescale, and then NXP bought Freescale. So that's why it's the Motorola Freescale NXP. Okay, sure. That makes sense. Let's see if we can't just quickly find a pinout. Pin assignments 11-1. All right. What page are we on? Let's go to page 100. Where's that put us? All right, let's go to 170. Oh, there we are. Okay, look at that. Okay, good. So it's not in this, well, of course it's not in the same order. Why would it be in the same order? That makes no sense. Let's make sure. So D5 here is 64. This is 64. Okay, that looks correct. So we should be 64, 63, 62, 61. So D or 64 to 54. So 64 down to 54. Okay, data looks good. All right. Yeah, I'm just going to keep going around this circle. So A20 is in fact, yeah, okay. So these are split up. I wasn't expecting that. So A21 is on pin 50, then VCC is in the middle of the chip. Okay, that makes sense. I mean, it's a 64 pin dip. Come on. A20. And then let me check something real quick. So okay. So let's see. So those are all pretty easy. FC0 goes 28, 27, 26, which I think I did. 28, 27, 26, I did. Okay. And then we get into, okay, this makes a little more sense. Maybe I can just do it this way. I guess I don't really need to see the original now, do I? Yeah, so let's see. What is pin 13? Pin 13 is BR. Pin 12 is BG AC, and pin 11 is BG. Okay. Number 9 is DTAC. I got that correct. And then we've got read write, and then 8 is LDS and UDS. I wonder if that's like upper and lower data something. Okay, let's see, pin 6 was AS, and then D0 started 5, 4, 3, 2, 1. Okay, let's keep going around here. So let's go to 25 is IPL 0. IPL 1 is 24. So that was, I almost got that. Let's go for, let's see, UDS. No. IPL 012. What am I? I just got myself confused because I'm getting confused and I'm going back and forth. I'm trying to go up the one we built. So 8 is LDS, 10 is DTAC. I verified that. 21 is VPA. 7 is UDS. I think I already did that one. 15 is clock. All right. 17 is halt. And then the address lines. Okay. So then if I come back over here, 20 is E. Where'd it go? E. And then 16 is, I have 16 as ground. So this must not be 16. I wonder if that's like 18. Yep. That was supposed to be 18. It was 18. And then I'm going to type or spell this out. All right. So then AS I already checked. Okay, 22 is BERR, burr. 68,000 goes burr. VMA is 19, IPL. Okay. And then we got those. Cool. All right. So I'm going to do real quick. I'm just going to run the symbol checker. And like one thing this would have actually, let's try this. I think what this would have actually found is it would have told us that 2 pins were on named pin 16. Yeah. So it's not super detailed, but it catches a lot of like really simple mistakes. Okay. So now there's a 48 pin version too. Huh. Okay, so what I would like now is, actually, you know what I'd like to do is save this before I forget. All right. So that's the pin assignments. What I want now are pin descriptions. So AS is address strobe. This 3-state signal. That's pretty much all I care. All right, let's go tri-state. Indicates that something is valid on the bus. Read write is a 3-state signal. Really? I didn't know that it was tri-statable. Okay. Well, we will make that tri-state then. Upper and lower data strobes. These 3-state signals and read write are for the flow of what control the flow of data on the data bus. That seems pretty understated. Okay, got that. DS is data strobe. Did we have a DS? I don't think we had a DS, did we? And that's on the 68008. DTAC is data transfer acknowledge. Ooh, I like that. It's an input signal for the completion of a data cycle. Okay. It's an input. Bus arbitration control. BR is bus request. Oh man, this is really nice to have such a clear data sheet. It's input. It can be wired or this input can be wired or with bus request signals from other devices. Okay, whatever. So it's an input. Bus grant is an output to let other potential masters know that they're giving up. Okay, and then I'll bet bus grant acknowledge is an input, because once you say you can have the bus, somebody else is going to say I have taken the bus. Yep. Oh, that makes so much sense. I get that. Okay. Where are we at? Interrupt control. Shocking. These are all inputs. I'm not surprised by that at all. Where's the other one at? Over here. So we'll just do electrical type, input. All right, note, the 48 pin only has 2 interrupt controls. Oh, that's nice. Okay, now we get to bus error. Burr. Burr. That's in my way. That is an input. Reset. Let's see, along with the assertion of halt, starts a system initialization. To reset the processor and the external devices, reset and halt must be asserted at the same time. All right, then. Okay, mode. I don't think we had mode. It looks like it's only on certain variants. E is enable. Aw. Is a signal, the standard enable signal common to all 6800. A single clock of E consists of 10 clock periods. It's generated by an internal ring counter that blah, 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 blah. Okay. That's funny. It is an enable signal, but it's a free running clock. Okay. Valid peripheral address. Input signal indicates something, something, something. Yeah, that's too many things. I'm not going to read it all. The WMA valid memory address is not the Video Music Awards. I'm going to guess those aren't a thing anymore. Processor function codes. These function code outputs indicate the mode and the address space currently being accessed. Interesting. All right. Clock is a clock input. Really? Oh, that's funny. Okay. And then the power supply pins, which I think is funny. They're using VCC, even though this is probably CMOS. Okay. So, did we get all of the pins? I see output, input, tri-state, input, input, tri-state, output, and sweet. Now we'll probably end up moving some of these around, but at least all the pins are here, and I think we've got the correct functions assigned. So I think we can move on.
Much rejoicing. Yay.
Yay. Okay. This symbol is done. I wonder, whoa, what just happened? Save. And the name, I'm going to name it MC 6800, and then for the data sheet I will actually throw in this URL since it's to NXP. Okay, so the next question we have to address is, do we yeah, I think we're going to go ahead and make like these ROMs, just because. Yeah, I think we'll make a couple of these other chips too, because if we plop this down right now, there's pretty much nothing to draw. So let's do a new symbol. No library selected. You're not a library selected. This symbol name, I'm just going to call it ROM. And we're going to do A0. Oh, they're still in the wrong direction. Okay. All right. 1, 2, 3, 4, 5, 6. So how many address lines are there? I see 14 maybe. 16. Right? And then nothing else. Yeah. So, and I usually, I don't know, sometimes I'll try and use like a standard ROM symbol and then just modify it. I just feel like that's just as much work as doing this. So I just figure we'll just do it real quick. 7, 6, 5, A6 is 4, 3, A8 is 25, 24, 21. Is that 23? I think it's 23. That seems like a way that a ROM would get wired, you know, completely illogically. Because A12 is pin 2. 13 is 26. 14. Oh, we'll have to move these around in a minute. Is 27. A15 is probably 1, right? Isn't that usually like the one of the high bits? And 16 is 22. All right. Cool. 1, 2, 3. All right, so we'll move those. I will X to swap them around and Y to turn them upside down. And then we can go to about here maybe. Looks good to me. Okay, so now we have, are those O's or D's? They look like O's to me. But they're data, right? Oh, and you know what? I see what they're doing. They're saying 0, 1, 2. Okay. I know what's going on. I get it now. So let's do another pin. And these are going to be probably tri-state. And let's see, do they go in order? They do. So we'll do O, or O, 0 on 11. All right. And then we get 12, 13. Oh, this is 15. 16, 17, 18, 19. Yas. Okay. So now we have another input. We'll do P for pin. It'll be chip enable, which I actually suspect is an output enable. Or internally, they must be tied together or something, because you would normally leave chip enable just on, and then you would do output enable, right? I don't know. Maybe I misunderstand how those work. Okay, so output 0 should line up with A1. Oh, these are all backward. Let me hit X to swap those around. That's better. And then we can move these in a little. No, wait. Wait, these are all backward. It's supposed to look like that. Yeah, these are wrong too. There we go. That's much better. Okay. We need some power pins. So let's do P, ground, 14, power input. Why is this off grid? Uh-oh, my grid changed. I thought the override was supposed to fix that. Yeah, what the heck? Let me just try and move these now. Maybe that fixed it. I find that suspicious. Chip enable, these are off. There. I don't like that. All right. And then we'll put this pin up here, and this will be VCC, and that's probably pin 28. I see a 27, so it's got to be a 28. Okay. So we've got a 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that looks right. And then these look pretty good to me too. Okay. Let's do a polygon. All right. Let's move that up. Who is in the mid? Oh no, let's move this at least 1, 2. That looks pretty good. Where's the middle of this box? It is right at the 3. All right, let's move that over. All right, so I want to try and move this all over by 1. Nope, that's 2. That looks like 1. Well, doesn't matter. It's in the center now. All right, that works for me. Yay. Okay, a couple things. Let's move this up here. Doesn't really matter. For some reason, I don't understand where you put the field designator. It never works the way I think it should. All right, so I'll take care of the 2 ROMs. And then I see we're using some 245s as well. Oh, what the heck? Oh, come back. Come back. Okay. Let's go and get these 245s because I feel like if we can get the CPU, those 2 ROMs, and the 245s, that's a good chunk of stuff. And then, yeah. Well, actually, we'll just keep going around the symbols for the moment. Okay, so for the 245s, what I'm going to look for is, I know these are already in the library, but their pinouts rarely ever match the schematic. But at least what we can do is we'll just use this existing symbol and modify it. So what I'll do is I'll save copy as. Yeah, I'm going to add an SE to the name just so that it's because it's a variant for this schematic. And then we can hit save. No. All right, so now if I do 74LS245 SE, I can open up this one and we can hit save on that. Yes, okay. So now we can move around all the things. All right, so first thing I'm gonna do is I hate how you can't turn these layers off. Okay, so first up, it's backward. Nice. Are these both the same? Okay. It's instead of A and B, it's B and A. Hey, 4MB, thanks for saying hello and kind words. Thanks for stopping by. All right, so we're going to do X, Y, 11, 12, 13, 14, 15, 16, 17, 18. Okay, this is actually pretty easy. And then that means this has to stay the same because the 245 is basically mirrored on its 2 sides. I think one pin is offset from the other, but at least the inputs and outputs are aligned with each other. Not like I don't know if it's the 244 that's really messed up, but there's a buffer where it's like input output instead of input output, which makes so little sense to me. I don't know why you would do it that way, but there must be a reason. All right, so then these will hit Y and turn those upside down as well. Oh, I think that's what's throwing it off the grid. Okay. I'm not going to worry about it right now, but that's what it feels like to me. All right, and then this is going to go over here. All of these can come down a little bit, and this can come up a little bit. I don't see why not. Okay. 1918. Okay, so okay. I hate when they do this. Now this doesn't make sense. They labeled it B0, 1, 2, 3, 4, 5, 6, 7, but then they labeled it A, 1, 2, 3, 4, 5, 6, 7, 8. Why would you do that? Like, seriously, why would you do it that way? Because B0 and A0 line up. It's not 17 to pin 2. That is really weird. Like, I don't know why would you do it that way? I'm not doing that. I don't think I can't do something I can do a lot of dumb things, but I can't do something that's that dumb. Okay, so now those 3 or 4 are done. What do we got up here? This looks like an F257. So I wonder if that's a 74 F257. I think it is. Let's see. ZA is pin 4. Yep. Okay, so we're going to save as. This will save this as. So F, man, maybe the 6800 isn't CMOS. Because why would you use a LS buffer with a CMOS chip? You wouldn't. You would only use it with a bipolar. And F, I think, is... because S is low power Schottky and F is fast. So, yeah. Huh. All right. Same thing. I am going to call this SE, even though it doesn't exist. The F doesn't exist in the library, but that's okay. All right. And then we'll double click on that one, hit save. And now we can mess up all of the pins. Yay. All right. So what do we have? 10 and 11 are going to get swapped, and then they're going to go near the top of the part. So I don't know. I'm just going to put these up here for the moment. I can't tell what this pin number is. Is it 9? What is 2D? I can't tell. All right, so 14 and 15 are basically down on the bottom. 1 is going to be over here. I think this is going to go 15 and then 13 and 14. 12. Wow. Okay. 12 goes over here for reasons. And then this, oh, what are you doing? Why'd you do that? What are you doing? KiCad. I'm going to start calling you the wrong name if you're going to do this. All right. And then 10 and 11. Still not sure. Oh, maybe that's ZD. Okay. Oh, come on. So let's go ZD. Let's move you up here. All right. And then 2B, maybe, or ZB. Yeah, I'm getting there. I'm almost there. Because ZA is going to go right about here. And then ZB is coming right about there. And then that means this one is roughly there. 6 and 5 goes here. And then both of these look like they're in the middle of the chip. And then these, let's go 13 and 14. Maybe about there. And then I'm missing these two, which is 2 and 3. And they probably line up something like this. There. I think I am going to move these down just a little bit. That looks a little better spaced out. All right, there we go. We got our 74 F257. I hope these don't go bad often because that's going to be hard to find. Although maybe there's a HCT that would work. All right. Now what's going on here? This looks like some kind of connector. This doesn't feel like enough chips. Like, where's the IWM? And the serial chip. Because I don't think all that stuff is, it's not all built into the gate array. I don't think. And sound, where's the sound chip? Is there like this looks like power supply. 3759. Sounds like a video chip, but maybe that's a switch mode. These look like, yeah, this is the power supply. Okay. And then the analog board, but the analog board is not going to have, huh? Yeah, I feel like there should be an IWM and a sound chip. I don't think that, okay, I realize this now. This is not the whole schematic. We're missing something. So let's see what this looks like. Macintosh schematics, SE, gate array, RAM ROM, page 2 must fix this. Okay. Okay. Oh, very well. Okay. That's fine. We need the parts anyway. So this looks like a nightmare. However, it's not labeled at all. So maybe we can get away with this. Okay, let's do a new symbol. No library. Okay, hold on. Save this. Let's do new symbol. The name is going to be gate array. Make sure it went into the right library. Yep. All right. So 79, 78. Good Lord. This is a nightmare. Okay, so let's do 22 power input. And that will be 64, I think. Ah, that's the name, not the number. Whew. Okay, so this one we'll do 64. Put that one here. All right. Come on. Come on. Come on. There we go. All right, then I've got 1. And I'm guessing it's 21. And then I'm going to guess this one looks like 43. And this one looks like 83. And we're just going to have to see which ones get overlapped. Okay. Now, I'm going to leave almost all of these unspecified because this is, I don't know how we're going to figure this out otherwise. So 79. And then I think this is 78, not 89. What do you... Oh, come on. All right. Move this up. Move that up. So let's do a pin. I think that's 76. This is not, it's so illegible. Like, should have done this earlier. All right, let's see. Okay, so that's what I already have. So that's not, yeah. Wait, nope. Actually, this one is slightly more legible. So hold on. It's because I can actually see the numbers in this one: 79, 78, 76, 73, 1, 2. So this is slightly more legible than the other one that I'm looking at. I don't understand how that works, but I wonder if somebody just cranked up the contrast. That's kind of what that looks like. Okay, and then let's see. I'm just looking at links. Didn't I have an Apple? Oh, that was the one. What is this for? Wait a minute. Hold on. Hold the phone. I downloaded these already. I don't remember where I put them. Hold on. Let me go here. Bormac. Here. Yeah. Actually, I have them right here. Wait a second. What's under Apple? All right, so this is basically the same one. So nobody has the full schematic is what I'm getting at. And then I don't know who Bormac is. Bomark. But did they reverse engineer it? Not the SC. Darn it. Oh, darn. Okay. Okay. I'll just keep going with what we've got because it's what we've got. But yeah, this is, like I said, yeah, that sucks. Okay. Let's go another pin. So 76, 73. I feel like what's going to end up happening is I'm going to have to go and get my logic board and start going through it and ohming out some of these connections, at least to verify that things are where they're supposed to be. It does bother me that this isn't complete though. It's missing, it's missing stuff. All right. So that looks like 68. $67, 60, wrong direction. I'm going to do 65 so that I can just get 7 and 8. Hit Y, swap those, and then put that there. All right, so this is now 14, 15, I'm going to guess 16. I have no idea. So let's do 14. Did it again. Let's do 14 and then 15, 16. Y. All right. And 20. Let's do that. Actually, 20. Shoot, I should have just done 18, 19, and then we'll move that one up here. All right, so 20, 19, 18. That looks an awful lot like 69. Hey, Tim, how you doing tonight? 69, and then we got 72, 74, 75. 72, 74, 75. What did I do? What did I do? So I've got 74, 75, 77. That looks a lot like 80 and 81, but did I already? No, I was okay. I thought 81 was one of the power pins. Okay. All right. 81. Then we get 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Of course. That's probably a ground. All right. But at least we can do this and say 2, 3, 4, 5, 6, 7, 8, 6, 7, 8, 9, 10, and then 12. It's another Monday. Yeah, it's Monday somewhere, isn't it? All right. And then I'm going to do this for the moment. I'm going to do, because I want to try to line these up, and I think I've got an idea of how to line them up, but I want to get them created first. I think this is 38. And then this would be 36. And this is 37. 37, because I think it looks to me like it's 37, 38, 36. 38. But then this looks like 47 and 30. I don't know. Okay. 50. So it goes 1, 2. So it goes 1, 2. Skip 1, 50, I think. I think this is 58. I guess 54. I guess 52. And now 41. This looks like 3W. I feel like I'm in an eye exam. Oh my God, 51. I think this is 41. Well, I thought this was 54, but it can't be. So it's, I'm just going to put 50 question mark. Okay. This is unbelievable. All right, I'm gonna end here. So yeah, we'll I think we'll pick this up next week. I don't know. I might have to punt on this schematic and do something else. So, all right. Well, hey, Sam, you're just in time. I'm logging off. So, all right, guys, thanks for hanging out. Keep an eye out on the channel. I've got a Adams video coming. Hopefully get it out by Monday, but we'll see how it works out. So, all right, guys, hope you find time to do something you enjoy doing and share it with others. Until then, see you later.